Yes students, welcome to the next video lecture. Now students, first of all today we'll do two new concepts. The first concept is difference set and the second concept is disjoint set. I think disjoint set we have already discussed, but then also students, once again we will discuss. Now first of all, how to find difference of two sets, say A and B. Now let us consider this with an example. Say students, we have two non-empty set. Set A is equal to A, B, C, and set B is equal to B and A. Now if I want to find A minus B and B minus A, students, we want to find A minus B and B minus A. Now while operating A minus B, we check the first set is A. So from A, remove the common elements of A and B, which is small b. So from A, if I remove small b, the remaining elements are A and C. And if it is B minus A, from B, remove the common elements of A and B, so this will be N. So if you carefully observe, set A minus C will exclusively belong to A, and set B minus A will exclusively, students, belong to set B. So once again, to have A minus B, difference of A and B, from A, remove the common elements of A and B, and to find B minus A, from B, students, remove the common elements of A and B. So students, if I want to define different set, let A and B be any two non-empty set, then the set of elements only present in A but not in B is defined as the different set A minus B. And similarly, the set of elements only present in B but not in A is defined as the different set, students, B minus A. So this is how, students, we operate difference set. And disjoint sets, of course, I have told in the last lecture also, for any two non-empty sets. If their intersection is null set, students, then such sets are called disjoint sets. Say if A and B are non-empty sets and A intersection B is equal to null set, then A and B are called disjoint sets. Say suppose there are three sets A, B and C, and A intersection B intersection C is null set, then we can call the three sets, students, A, B and C as disjoint sets. So this is what was the concept for today. Now let us apply our concepts to the sums and complete, students, exercise 1.3. Today we will be completing exercise 1.3. Now let us start with the 7th question. X says that X is a natural number. Now if I am going to list all the elements of sets A, B, C and D, students, the sets are given in property method. Based on property method, students, I am trying to list the sets in listing method. A is equal to X such that X is a natural number. Now students, the set of natural numbers, starts from 1. So 7th question, set A is set of natural numbers, so 1, 2, 3, 4, 5, 6 up to infinity. B is equal to X such that X is an even natural number, students. Even natural number starts from 2. 2, 4, 6, 8, 10, 12 and onwards. So this is 2, 4, 6, 8, 10 and onwards. Then C is equal to X such that X is an odd natural numbers. So 1, 3, 5, 7, 9, 11, 13 and onwards. And D x such that x is a prime number, and of course it is a natural number. The first prime number in terms of natural number is 2. So d is equal to 2, then 3, then 5, then 7, then 11, then 13, then 17 and onwards. Okay students, now what we are supposed to find first is A intersection B. Come on, what will be A intersection B? The first answer is A intersection B, and that will be B itself. You can check, because B is subset of A. Even natural numbers is a subset of set of natural numbers. Then A intersection C. Okay, second answer, A intersection C will be C, because C is also subset of A. Then third answer, A intersection D. A intersection D will be also D, students, because D is also a subset of A. Then fourth answer, B intersection C. B intersection C is definitely null set, students, because we can say that B and C are disjoint sets. If intersection of two sets is null set, students, such sets are called disjoint sets. Then B and D. Fifth is intersection of B and D. Intersection of B and D is only singleton set 2. Students, it is only singleton set 2. A set having one element is called a singleton set. An intersection of C and D. Okay, what is common between C and D? Then come on, what is, students, common between C and D? 3, 5, 7 and onwards. So that you can easily do on your own, students. Now students, 8th question. The next concept is, students, the 8th question. Which of the following pairs of sets are disjoint? Just now, students, we have done the definition of disjoint sets for any two non-empty sets A and B, students. If A intersection B is null set, then set A and B are called disjoint sets. Okay, let us do question 8. Now in that, the first set is set A is equal to set of elements 1, 2, 3, 4. Question 8, first part, set A is equal to set of elements 1, 2, 3, 4. And set B is equal to x such that x is a natural number and 4 less than or equal to x less than or equal to 6. So it is 4, 5 and 6. So A intersection B is singleton set 4, which is not equal to null set. So A and B are not disjoint sets. It is very simple, students. Then, students, second pair, the set is A, E, I, O, U, all the vowels in English alphabets. Set A is equal to set of elements A, E, I, O, U, and set B is set of elements C, D, E and F. C, D, E and F. We can say that A intersection B will be singleton set is still not equal to null set. So this pair is also not disjoint. Now the third pair, students, x such that x is an even integer. Just now in question number 7, students, it is set number B, and x is an odd integer, it is set C, so B intersection C is null set. So the third pair, students, is disjoint. First and second pair, students, are not disjoint. You can say the third pair is a disjoint set. Now, students, the next is to find different set. Here also, students, lot of options are given. So let us do the ninth sum. Set A is set of elements 3, 6, 9, 12, 15, 18 and 21. Okay, ninth sum. Set A is set of elements 3, 6, 9, 12, 15, 18 and 21. You can carefully observe, students, all these are multiples of 3. Set B is equal to 4, 8, 12, 16 and 20. 4, 8, 12, 16 and 20. Set C. This all are multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16. And D all multiples of 5. So 5, 10, 15 and 20. Okay, students, let us go for odd questions. Operate A minus B. Okay, students, I am operating all odd parts. The first part is A minus B. Okay, I am writing the third part. Let us do three parts together. It is A minus D. And the fifth part is, students, C minus A. Okay, now all of you concentrate. Once again, how to operate, students, A minus B. To get A minus B from A, remove the common elements of A and B. First of all, cite out which are the common elements of A and B. Students, citing out the common element, only 12 is common between A and B. So from A, if I remove 12, I will get 3, 6, 9, 15, 18 and 21. Now A minus D. From A, remove the common elements of A and D. The common element, student, is only 15. So if I remove 15, 3, 6, 9, 12, 18 and 21. Now C minus A. From C, remove the common elements of C and A. The common elements are, students, 12 and okay, I think the only common element is 12. Okay, so if I remove 12 from C, what I will get? 2, 4, 6, 8, 10, 14 and 16. So this is our answer of part number 1, 3 and 5. Okay, now, students, we are doing part number 7, 9 and 11. B minus C. Now, students, we are doing B minus C. Seventh part is B minus C. Ninth part is C minus B. Seventh part is B minus C. Ninth part is, students, C minus B. And 11th part is to find C minus B. Okay, let us find the sets. B minus C means from B, remove the common element of B and C. Which are the common elements of B and C? Then I can say 4, 12 and 16. So remove 4, remove 12 and remove 16. So we will get 8 also, sorry. 4, yes, 4, 8, 12 and 16. 4, 8, 12 and 16 students. If I remove, then the remaining element is only 20. So students, B minus C is singleton set 20. Now students, operate C minus B. From C, remove the common elements of B and C. So from C, if I remove 4, 8, 12 and 16, so what will remain? 2, 6, 10 and 14. I'm removing 4, 8, 12 and 16. So 2, then 6, then 10 and then 14. Then C minus D. From C, remove the common element of C and D. The only common element, students, is 10. So if I remove 10, then I will get 2, 4, 6, 8, 12, 14 and 16. So students, this is how we operate different set. So one must be very careful, students, in finding the difference set. Okay, now students, the next question is question number 10. Now check, students, question number 10 is very easy. X is equal to set of elements A, B, C and D, and Y is equal to set of elements F, B, D and G. Okay, let us note down, students, question 10. Now students, all of you pay attention. X is set of elements A, B, C and D. X is equal to set of elements A, B, C and D, and Y is equal to set of elements B, D, F, G. All of you know very well, students, in set, the order in which students elements are written is not important. Any element, students, can be written first and any element can be written at the last or in between. Okay, find X minus Y, Y minus X and X intersection Y. Okay, three sets we have to find. The first is, students, X minus Y. Second is Y minus X. And the third is X intersection Y. Now what is X minus Y? From X, remove the common elements of X and Y. What are the common elements of X and Y? B and D. So if I remove B and D from X, I will get AC. Now find Y minus X. So remove B and D from Y, so I will get FG. And X intersection Y is of course B and D. This is your answer, students. Carefully observe. This is your answer. Now students, the question number 11. If R is the set of real numbers and Q is the set of rational numbers, then what is the set R minus Q? Okay, now students, again, this is the question which is to be very perfectly understood. All of you know the sets of numbers. N is set of natural numbers. Z is set of integers. Q is set of rational numbers. A rational number is written in the form of P by Q, where P, Q are integers and definitely Q not equal to 0. Then I told I or T, which is set of irrational numbers, and then students R, set of real numbers, and the most advanced set of numbers is C, which is set of complex numbers. So that much, students, all of you must perfectly understand. Now what is given from R? If I remove the set of rational number from real number, students, if I remove the set of rational number, then students, the answer will be set of irrational numbers. It can be denoted by I or T or whatever notation, students. Notation may change from author to author, but concept remains universal. So R minus Q from real numbers, if I remove all rational numbers, the remaining will be all irrational numbers. Now I think the answer, students, you can write very well on your own. Now students, the next question, state whether each of the following statements is true or false. Justify your answer. So again a debatable topic, students, again a debatable question. Justify, this is not what you have done in standard 2 or standard 3, that for a correct statement you put a tick mark and for a wrong statement you put a cross. Students, it is not like that, true or false, which you have done. Now 2, 3, 4, 5 and 3 and 6, sorry, 3 and 6, yes, are disjoint sets. Now students, we have to justify whether the following statements are true or false. Let us note down the sets. Okay, first set is 2, 3, 4, 5. Question 12. The first part A is set of elements, sorry, 2, 3, 4, 5. 2, 3, 4, 5 and B is set of elements 3 and 6. Now A intersection B is singleton set 3 and therefore it is not equal to null set. So in the statement they have given disjoint set, so the given statement is false because A intersection B is a singleton set. So the given statement is false. This is the justification, as A intersection B is a singleton set 3 which is not equal to null set, therefore the given pair is not disjoint. Okay, A, E, I, O, U and A, B, C, D are disjoint sets. Okay, the first set is of vowels and the second set is A, B, C, D. And A intersection B is singleton set A again, which is not equal to null set. So the given statement is again false. They have told that these are disjoint sets. So students, you can very easily understand that statement 1 and statement 2 are false. Okay, let us go for the third statement. Set A is 2, 6, 10 and 14. Set A is 2, 6, 10 and 14 and set B is 3, 7, 11, 15. Now here definitely A intersection B is equal to null set, therefore the given sets are disjoint sets. This statement is 100% true. Now students, the last pair you can do on your own, 2, 6, 10 and 3, 7, 11. Set A is set of elements 2, 6, 10 and set B is set of elements 3, 7, 11. Therefore A intersection B is equal to null set. Hence students, this set are disjoint sets. These sets are disjoint sets. So students, this completes our exercise 1.3. Now students, 1.4. Sorry, this was exercise 1.4. Now students, we have completed up to exercise 1.4. Your prime concern is to complete all the sums of exercise 1.4, once in fair book and once in rough book. Study the concepts of different set and disjoint set, students, very well. Now students, the next topic of exercise 1.5 is the topic of complementary set. I think all of you have studied complementary set in standard 8 also and standard 9 also. So this is going to be fun, and the most important about complementary set are De Morgan's law. That I think all of you have understood, or we'll discuss it once again in detail. So students, here we conclude the lecture. We will start with the definition of complementary set and its properties in the next lecture. Thank you students. We conclude.